Conversion from decimal to binary. In this module, our objectives are as follows. Learn the arithmetic process involved in converting decimal numbers to binary and vice versa. Understand the two notation methods used in writing the solution of the conversion process and gain mastery on the use of both. Understand the long and short methods used in the checking process of the result obtained. Just a heads up before we proceed, two gorgeous ladies will be taking turns in presenting this segment to you. Now, for the course proper. Conversion from decimal to binary is a straightforward three-step process. First step is identifying the given number, whether it's integer, fraction, or a mixed number. If the given number is an integer, then successive division by 2 is the next process. If it is a fraction, then the next step is successive multiplication by 2. If it is mixed, then you will have to do both processes, or arithmetic operation. Last step is the checking of the result obtained. You may choose the notation method you are comfortable with unless stated otherwise in the problem. When converting decimal numbers into binary, you are simply expressing a decimal value using only the numerical symbols 0 and 1. Think of it like you are asking how much of these zeros and ones are there in that given decimal value. There are two possible arithmetic operations involved. For integer conversion, as I have mentioned earlier, it's the successive division by 2. But when it involves conversion of fractions, the operation to be used is successive multiplication by 2. To proceed in the conversion process, you only have to be sure of three things.
First, ensure that the given number is a decimal or in base 10.
Second, have in handy your arithmetic division skills, mindful of what the dividend, the quotient, and the remainder is.
Third, enough space to write your solution legibly.
When you have this, you are surely ready for the task. As I have mentioned, converting decimal to binary is a straightforward process. Let us discuss the operation with integers first.
Simply successively divide the given decimal number by 2, taking note of the resulting remainders, which are either 0 or 1, until the last quotient obtained is a 1. Write the last quotient 1 in the series along with the remainders obtained, starting from the most recent and ending with the first.
There are two ways to write or note the successive division process. First is the conventional or longhand notation. Here, the solution is presented using the expanded notation and are expressed in rows. Second is the shorthand notation. Here, the reverse shorthand division symbol is used and the division process occurs in a vertical manner. To fully understand the process, let's work on a very easy example. Let our case be convert decimal number 10 into a binary number. Follow the procedure and be guided accordingly. First, rewrite the decimal number providing enough space to include the quotient and remainder along the same line, and then in the succeeding lines, including the divisor too. So here we write the given decimal and labels for the quotient and the remainder. Now we'll do the first division. Divide 10 by 2. That will give us a quotient of 5 and a remainder of 0. At this stage, 5 now becomes our new dividend. Divide 5 by 2, giving the latest quotient of 2 and the remainder 1. 2 is now our new quotient and is still not equal to 1. Therefore, we will still proceed with the division process. 2 divided by 2 gives the quotient 1 and the remainder 0.
When you obtained a quotient of 1, that is your cue to end the division process.
The last quotient of 1 becomes the beginning digit of the resulting binary number.
Combine the remainders obtained with the digit 1 in the sequence, starting with the most recent and ending up with the first. Therefore, the decimal number 10 in binary is 1010.
You can actually check if the binary number you obtained is correct, so let's check the result we've got using the long method first.
The procedure is also a three-step process.
Write the binary number and multiply each digit to its positional value.
Second, compute for the partial products. And third, sum up the partial products. The sum obtained should be equal to the given decimal number.
Starting with the rightmost digit, 0, let's copy that and multiply it with its positional value 2 raised to 0, which simplifies to 0 times 1, giving the partial product 0. Next is the digit to the left, 1. Multiply it by 2 raised to 1, simplifying the expression to 1 times 2, giving the partial product 2. Then we have the third digit 0. Multiply 0 by 2 raised to 2, which simplifies to 0 times 4, giving a 0. Then the last digit, 1. Multiply it by 2 raised to 3, This simplifies to 1 times 8, resulting to 8. Summing up the partial products, we'll have 10, which is equivalent to the given decimal number. This time, let's check using the short method. In the short method checking, the binary positional values are written directly above or below each binary digit, taking note of the values of those that correspond to the digit 1, and then finally taking their sum. In this example, the digits that correspond to the ones are those of 8 and 2. Sum up the magnitude values of the non-zero digits, the binary ones. In this case, starting from the leftmost digit going to the right, they are 8 and 2. Therefore, 8 plus 2 is equal to 10. The two checking methods are just the same except that the notation in the short method is more direct and quick but informal.
This method serves best when you are checking solutions for your personal reference.
Let's now convert decimal numbers into binary using the shorthand notation method. Working on the same case, convert the decimal number 10 into binary. Do you still remember the way we used to do shorthand division? We use this division symbol, remember? Now, with successive binary division, a similar symbol is used, only one that is flipped to the horizontal or x-axis, like this. So when we do successive division, we write the dividend and the division symbols this way. The divisor, which is 2 in this case, is written adjacent to the left. The quotient is written directly below the dividend and the remainder is written on the same row as the former dividend, but on an adjacent separate column. So that is how we note the division process. If the quotient obtained is not equal to 1, then the division process continues, where the latest quotient becomes the new dividend. The successive division continues until a quotient of 1 is arrived at. To demonstrate the process, let's first clear the screen and redo the same case. Now, let us solve. 10 divided by 2 is equal to 5 with a remainder of 0. The quotient obtained is not yet equal to 1. Therefore, continue dividing. Our new dividend now is 5. So 5 divided by 2 is 2 with a remainder of 1. Is the new quotient equal to 1? No. Therefore, continue dividing. 2 divided by 2 is equal to 1 with a remainder of 0. Is the new quotient equal to 1? Yes. Therefore, this is our cue to stop dividing. The latest quotient of 1 becomes the beginning digit of the binary number equivalent. Attach in series the remainders obtained starting from the most recent and ending with the first remainder obtained. The resulting binary value is 1010. Therefore, the decimal number 10 in binary is 1010. Let us check our result. First, using the long method. Please follow through this process. Or using the short method as follows. The short method checking contains no magic. The next short method illustration explains how the magnitude stayed as 0. The magnitude value was multiplied to the binary digit, and since the general rule is that any number multiplied by 0 results to 0, in the short method process, they are automatically listed as 0. I hope that clears the mystery now. In the next video, we will have more examples and exercises for integer decimal to binary conversions, followed by the decimal fraction to binary conversion, plus more exercises. Nevertheless, before we end this video, here is an exercise consisting of one item to gauge your understanding of what was just presented, the decimal integer to binary conversion process. The solution is available at the end of the video. Please do proceed to the next video for the continuation of our discussion after completing this exercise.